Alright, today we are going to learn about Cramers rule. This is the next way of solving a system of equations. And remember, when you're solving a system of equations, it's finding where the point that the two equations have in common. For your notes for having proof of this, you need to make sure you write down the formula for Cramers rule, and I'll point that out again. So make sure you have that formula in your notes. If you don't have enough time to write it all down on my slide, pause the video and write that down. Okay, so this is what I'm going to be looking for when I'm talking about what you have in your notes. Okay, this is the review slide I promised would be on here. It just goes through, in case you haven't written it down yet, the steps for elimination. It goes through the steps for substitution and the different ways of graphing, which are the other three ways we've talked about how to solve, all which are going to be on your test. So make sure you know how to do elimination, substitution, and graphing. Okay, so if you haven't gotten an opportunity to write those in your notes at some point, it is crucial you have those in your notes to understanding those processes. Now, what is Cramers rule? Cramers rule is basically a formula that once it is in standard form, I just have to take the numbers from that and put it into a matrix and solve that determinant of the matrix. So really, it's just a formula for solving a system of 2x2 equations. Some people like this better because they don't have to go through and worry about all the mistakes they can make in the math process. But the problem with Cramers rule is you have to have that formula memorized. Okay? Elimination, we went through the last couple of days. That's when I add the two equations together to eliminate. This is probably people's favorite method, but you can make a lot of little mistakes, like not multiplying by a negative for some of the parts or adding wrong. So it's one of people's favorites, but there is a lot of places you can make little mistakes. We also went through substitution. Substitution is replacing with an equal value. It always works, but sometimes you have fractions. So some people don't like this in some cases because of the fractions you would get. And then graphing is a great visual of what you're finding, but sometimes it doesn't fit on your graph paper because you have really large numbers, or sometimes you have fractions as answers, so that doesn't work very well either in those cases. Cramers rule, this is what you need to write down in your notes. First of all, I'm going to set them up in standard form. So I'm going to have both equations as ax plus by equals c. Okay? And we've learned how to do this, we've reviewed this. It is really important to put those in standard form. Then I'm going to set up three determinants, three matrices that I'm going to find the determinant for. One of the matrices I call the D matrix, the D determinant, is these values right here. So A's and B's go into those columns to make your four numbers. This is the determinant that's on the bottom of both of your answers. The second one you're going to find, if I'm looking for the x part of my point, so I call this determinant x, I'm going to take where the x's were here and replace them with the numbers at the end, and I leave the second part exactly the same. So this is the c and the b values, not the x numbers. So I'm using these numbers in those order. And then the last one, for my y value, I'm going to replace the y's with the c's. So I use the x and then the c's for those values. And I find the determinant of all of them. So to find the x coordinate, I take this x matrix and this original one and divide them. For the y one, I take the y matrix and divide it by the original. You do not have to find this matrix twice. Find it once and then know it's on both of your bottom of your equations or your points. So let's go through a couple of examples. So I have up here, in case you still haven't written those down, those are the matrices I'm trying to find in standard form. So these are already in standard form. So the first thing I'm going to do is find that D matrix. all I'm going to do is take these numbers, 5 and 2, and negative 2 and 4. Don't forget that negative. So that's one matrix. I'm going to take this matrix that we just found. Okay, so I just rewrote that exact same matrix. This time for x, I'm going to take where the x's were and replace it with the last numbers. And then for the y one, again, I'm going to take this original matrix. Oops, I did not want that line. Put that back. And again, I'm going to take that original, but this time I'm going to replace the y's. Oops, not with c's. Excuse me. With the numbers. Somehow I lost that. Okay, so that's my three matrices. Okay, I'm going to find the determinant of these. So remember, how do I find the determinant? I multiply 5 and 4. I multiply 2 and negative 2. And I subtract those numbers. So 20 minus a negative 4 is 24. That first number is going to go on the bottom of both of those numbers in your point. Now I'm going to find the x. So I'm going to take negative 10 times 4 and 140 times negative 2, and I'm going to subtract those numbers. So negative 40, negative 180, nope, 280. Two negatives make a positive. So negative 40 plus 280 is 240. And then the last one, I'm going to find the determinant. So 5 times 140. All right, I don't want to make a mistake. 5 times 140, 700. I'm going to take 2 times negative 10, negative 20, and remember I subtract them. So that is 720. Now you're almost done. I just need to simplify this. So what does that equal? 240 divided by 24 is 10. 720 divided by 24 is 30. You still can check these. I'm going to check this one problem. So I'm going to put 10 in for x, 30 in for y. So 10 in for x, 30 in for y. I want that to equal negative 10. So I'm going to put that in my calculator. 5 times 10, 50, minus 2 times 30 is negative 10. So that works. Okay, and then I'd also put those in both here. So 20 and 120 does add up to 140. So now I know this is the right answer. So what did I do? And we're going to do 2 more problems, but before that, I found my 3 determinants, my matrices, then I simplified those numbers and wrote them in my point.